Hello and welcome to Maths with Jacob. This lesson will focus on circle geometry. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. This is a very tricky puzzle, so if you get this out, you're doing very, very well. If you would like to subscribe now, please do so here. Otherwise, you can subscribe at the end. This video will highlight 6 basic rules which are relevant to the geometry of the circle. Knowing these rules will help us when we are asked to find unknown angles and side lengths of geometric shapes drawn within and around the circle. Rule 1. The angle in a semicircle is a right angle. What that means is that angle ABC is 90 degrees. So this angle here, that one there, is 90 degrees. This is a very, very important rule, and it will help us to solve a lot of geometric problems to do with the circle. Rule 2. A tangent is perpendicular to the radius drawn to its point of contact. So when the radius makes contact with the circle at the point T, and a tangent is drawn so it touches the circle at point T, angle STO is 90 degrees. So that's a right angle. That's quite straightforward. Two tangents which can be drawn to a circle from an external point are equal in length. So here's the first tangent AB. There it is there. There's the next tangent BC. They touch the circle in one point. That tangent there touches the circle at the point A. This tangent here touches the circle at the point C. Those two tangents are equal in length. So the length of AB equals the length of BC. The angles at the circumference of a circle standing on the same arc are equal. Okay, let's go through this slowly. Or what that means firstly is that angle AQB equals angle APB. In other words, this angle here is equal to this angle here. And why is that the case? Because look, they both stand on this arc. Okay? That's the reason. So see that angle there, standing on the red arc, AB. See that angle there, standing on the red arc, AB. When that is the case, both those angles at the circumference are equal. The angle at the center of a circle is twice the angle at the circumference standing on the same arc. In other words, angle AOB, that's this one here, is twice angle ACB. So, for example, whatever size this is, it doesn't matter what angle that is there, this is half the size. That's really all that it means. So, for example, just an example, if that's 100, let's say that's 100 degrees, that's 50. Okay? Excuse the writing, I'm not quite used to writing with this, but you've got the idea. If that's 100 degrees, that's 50 degrees. That's a very important rule too, and it comes in handy when we're solving quite a few problems. And the last rule, which is rule 6, the opposite angles of a cyclic quadrilateral are supplementary. This is what this means. It means that angle A plus angle C equals 180 degrees, and angle B plus angle D equals 180 degrees. In other words, if you add this angle here to this angle here, that gives you 180 degrees. And if you add this angle here to this angle here, that gives you 180 degrees. And it's called a cyclic quadrilateral because it's drawn inside a circle. So those 6 rules are very, very handy. And if you memorize those or remember them or understand them, you'll be able to do a lot of problems associated with circle geometry. Here's a quick quiz to help you, and please check through the video if you need to do so. The answer to the puzzle, what is the meaning of the following? Elevator out of order. How tricky is that? If you rearrange those letters, you'll get the word elevator. I told you it was hard, didn't I? Here are the answers to the quick quiz. Please check through the video if you need to do so. If you found this video useful, please subscribe on the next slide. You will receive a notification when the next video is available. Hope to see you next lesson.